So everybody, I will make you a presentation about the use of keystroke dynamics. It's biometric information what you can combine with password. So I will talk about that to try to enhance the security of his password, not to guarantee the security of the password. So I'm coming from France and belong to a research lab which is called REC. So this is the plan of my presentation. First, I will give you a quick overview about what I'm doing and what can an academic can do in the computer security field. After, I will focus on user authentication and things about, of course, password. And I will show you about the use of biometrics that could be useful to enhance the security of password, but also maybe, and I was thinking about that when I listened to prayer, that maybe could give also for, I would not say bad people, but people who have particular hobbies, to maybe help to crack password. We'll see. So, just a very quick presentation of the research lab. I belong to the Great Research Lab. We are 230 people working in the field of computer science. As we are many people, we are working on different research topics. And of course, today I will focus more about computer security. So in this research lab, we have 8 research units. And I lead one of them, which is called e-payment and biometrics. So in this research unit, we are like 30 members. We are working on 2 research topics. The first is biometrics, and the second is trust. When we talk about trust, we talk about computer security, security architecture, and also privacy. We are specific because our main application is e-payment, so we are strong links with banks and big companies working in the field of computer security in order to make payment secure, try to make it secure. And we are involved in many research projects with big companies. You have some logos on that. Very well-known company. Just focus 2 minutes on natural security. I don't know if you know this company. It's a very small French company working in the field of payment, but also combining biometrics. So if you have time, you can just have a look on their website, and I think they provide a good user authentication method using biometrics, but not only, with also something you mentioned by Per, something you can forget at home. So we are well known also because we have in our school e-banking platform composed of industrial products, where we are able to make real bank transfer in our school between 2 banks. So, just an overview about the research unit. And we work also on one topic, and I will focus on that, on biometrics. So, we try to define good solution for biometric authentication. So, I will talk a lot in this presentation about keystroke dynamics, but also we work on other aspects. We work on the evaluation of the biometric system in order to help in companies to choose the best biometric system to use for their application. And also we try to protect biometrics data because it's very sensitive. So we have algorithmic solution using, for example, what we call conservable biometrics. So it's a good way to protect your biometric data. And also we use secure element, and in France we like smart cards. So we use smart card. So it was just a very quick overview about what we are doing. Now I will focus on user authentication. So it's a different definition from there, but it's not far. Of course, personally I'm interested, of course, on password, but I'm also interested on the 2 last factors involving biometrics, morphological biometrics, what we are, when we say that we are something, and also the behavior of users, the way you do things can help us to recognize you, or also to profile you. So we are more interested in the two last, and we will show you how we can combine with password. So I was listening during the talk this morning and yesterday, and everybody agrees about password is not a good solution, a good usable solution, but still used. And I was wondering why, and we still use this password. And Udun talked about that and said, yes, because we use password because service provider wants us to use password. And of course it's very convenient for the service provider to use password because it's very easy to verify if it's correct or not. It's very simple to manage password. If you compare with one-time password, and I was surprised also not to hear about one-time password in the conference, maybe later. But if you use one-time password, the infrastructure you need is much more complicated. And nothing is cheaper than using your password, especially if you store it in clear text. And you have, of course, many websites that store a password in clear text. The consequence, of course, we have many usability lacks because, for example, you ask, and everybody talked about that, everybody asks to use complex password, people do not remember. And also, we didn't talk so much about privacy, but of course when we talk about password we think about security. But nowadays, as we have many service providers, we have to take care about privacy because many service providers make the business of selling data collected by the different service providers. So we have to take care a lot about privacy. I just took one website where defined the best practice for user authentication with password, and just put it on a kind of a cloud of words. And I think it is a very good way to present all the best practice. It's many things, nobody understands what to do. So, of course, using password is very difficult for the user, and especially when the best practices are different, given the person is telling what to do. Of course, why static password is not a good solution? Because of course it's not very convenient for user, especially when you have multiple services. Of course, Per talked about that, and we have many bypass strategy that permit also people to crack password, but also to access some personal data. And for privacy aspects, it's very bad. And one of the biggest problems with password is you have no real relationship, except if we consider, for example, the presentation this morning, when you have some association between some personal data and the content of your password, but most of the time you have a password and you don't have a real relationship with it. That's why I say, and it's very provocative to do that, but it's okay, so we will talk. I suggest to use biometrics. Why biometrics? Because for me, it's only one solution to make user authentication. When you talk about password, when you talk about token-based authentication schemes, you make a risk management of the user. You don't have any proof about the user is having the device in his hand. You just make a risk that says the probability that somebody has the device and the associated password is very low, so I can admit that. And especially in the field of e-payment, they take care about that. If you need to spend $1 million to correct something where the fraud is very low, they do not care. they let the fraud in. So, for me, biometrics guarantees the strongest link between the user and its authenticator, because you are the key. So, no more user authentication method guarantee this link with the user. Of course, when you think about biometrics, you think about very precise biometric modalities like iris, fingerprint, finger vein, and so on. But I think in the all biometric modalities, some of them could be useful to enhance the security of password. So I will talk about Keystroke dynamics. I don't know if many of you knows about Keystroke dynamics, but the main idea is about Keystroke dynamics is to store, to record the way you type your password. So it's not to replace, of course, the password checking. It's just to add something. We will verify the content of the password and also the way you type this password. It's not perfect, but I think it gives some interesting solution and also operational solution. So how it works? There are many ways to record the way of typing of somebody. You could think about, some researcher will think about the noise of making when you type your password. You can record the image, the video of your hand typing your password. But of course, in general, we use information provided by the OS, and especially we record sometimes. So we will record sometimes when you press the key, you release, and the flying time between keys. So it's very easy to do that for any OS, for any computer with a keyboard. And we will describe the way of typing with a vector, and I will show you an example. I will make you a demonstration on that. And with this feature vector, we will be able to compare if you are the right guy or not for a specific threshold. And the threshold, of course, will be related to the security you want. If you want to be very strict, you will authorize very low variation on the way of typing. And if you want something less strict, you will increase the threshold. So we defined in 2009 a software in Windows, sorry for that, but that gives that shows people how works Keystroke dynamics, and we provide also this tool for the research community in order to create benchmarks, in order to improve algorithm, in order to have a better security with Keystroke dynamics. So it's called Break Keystroke. We are very original naming our software, and you can find it very easily on the internet. So I will show you how it works. So this is the software we define, and we ask the user to type a password. So in this case, I should have changed, but I type laboratoire grec, meaning Greek laboratory in French. So you type it, and when you type your password, we measure sometimes about the pressure, the release, the time of release, and the time of flight. So if you use these focus, if you concatenate these focus, it describes your way you type this password for this specific password. Okay? So I can do it again. As you see, it's not perfect, but it's quite similar. So, of course, in this case for password typing, we say, okay, avoid complex password. Just type a password. Could be, of course, longer is better. No illusion. And in this case, somebody will be recognized because the content will be okay, and also the way of typing this password will be similar. Okay? So we ask people to use known password, or they can train. And after, in our case, we ask the user to type 5 times this password. And with these 5 captures, we generate a model, and we see that the model is not far. I mean, we generate a model of the way of typing this password for this user, and after we compare, we use this model for identity checking. Okay? So if you want to try, it's not the best. It's not the best version we have, because we use a very simple way. So you can enroll yourself, and you can also test your Keystroke dynamics by typing multiple times. It will show you the distance between the model and the capture, and based on the threshold you set, you will be accepted or not. So this is the main principle of Keystroke dynamics, and of course you can embed that on all websites very easily to capture the data, to send it to the server, and to make the verification on the server. Or it could be non-local also. So, what are the properties of Keystroke dynamics? So it's a 2 authentication factor, because you have to know something, and you have also to do something. It's password typing. I mean, how you type this password. So sometimes it's quite easy to get the password of somebody. It's much difficult to try to impersonate this person, to try to type like him. You can try. It's not so easy. It's possible, but not so easy. It has a good acceptance. We talk about a lot on usability, and we think usability is of course very important. It's very good for user because it's invisible, except the fact that they have to type 5 captures to register the Keystroke dynamics. After, when you make the verification, you have just to type a password. I mean, it's usual. And also, there's no privacy issue, because in biometrics, of course, it's sensitive data. If somebody catch your fingerprint, could be a problem, because you cannot change your fingerprint. So you can change your finger, but you have only 10 fingers. With your password, it's not a problem. Somebody caught your password? Okay, change your password. And you will have a new way of typing this new password, and based on the knowledge of the way of typing the first one, to be extremely difficult to predict how to type the second one. Then it avoids complex password, because choose a simple password or sentence, and we will recognize you when you type this password, even if you are very slow. If you use only one finger, it doesn't matter, because you will check the way of typing with your way of typing. And it's still a low-cost solution, because I told you about the good advantage of password use. It's very low cost, and in this case it's also low cost. We need a keyboard most of the time, except if you have tablet or touchscreen, something like that. Most of the time you have a keyboard, and we can embed that on the website. So you don't have to install anything on your computer. Everything could be installed on the website. And can be used on all computers. No more. So we think it is a good solution. It will not be the best solution, but I don't know if the best solution in computer security exists, but it's a good solution to enhance the security of password. So this is the ISO figure describing how a biometric system works. I don't know if you already seen that, but I will not describe it in detail, but you have 2 different processes when you talk about biometrics. The first is the enrollment, where you collect data to generate the model of the user. And the second is verification or identification, where you compare this biometric data with your reference. So you have many steps to realize this decision. One step which is very important, and we had very interesting talks about that, about the storage. Of course, we need to store this biometric information in a secure way. Of course, you need to encrypt the biometric data, but it's not sufficient. And when I say that, people say, "Wow, why it is not sufficient to encrypt biometric data?" It's because, and you are very good on that, nobody can guarantee that in 20 or 30 years, algorithm in place with the keys we use will not be broken. And I hope to be alive in 30 years. And the time I need to protect this particular data is much higher than other information. If you want to be powerful nowadays, maybe you can try to collect very young politicians to collect biometric data of this device, even if it's encrypted. Because maybe in 20 years, 30 years, this biometric information could be very useful. So, encryption is of course necessary, but not sufficient. So, there are many ways to solve these problems. So we work also on that, and we are not the only one, by using storage on secure elements, and also using particular algorithm, which is not far from cryptography, where we try to make it cancelable. So that means we do not store your fingerprint image or even your minutiae. Because even with your minutiae, if I collect your minutiae, I will be able very easily, with a public software, to generate a fingerprint image with having this minutiae. It will not be necessarily your fingerprint image, but my fingerprint image will have the same minutiae. So this is the different process, and you see there's matching between the reference that is stored somewhere and the capture to make the decision based on threshold, and the threshold is set for the security application you need. If you want to be very strict, you will have a certain threshold, otherwise you will change this value. So we began to work on Keystroke Dynamics in 2007, and we proposed in 2009 a first approach where we tried to test on the passphrase how to recognize people with the Keystroke Dynamics. So you have these two steps, verification and enrollment, and most of steps are done in the two cases. So I will not describe clearly all the steps, but we will collect data, we will make some pattern recognition techniques in order to learn how to recognize this guy. And for this application, everybody types the same text. And we try to recognize people only based on Keystroke Dynamics. And we try that because it was the worst case. Somebody caught your password, and we try to see, even if you know the password, if you are able to be authenticated. So we propose this method, and we made in 2009 also a benchmark, which is, I would say, in the top 2 international benchmark in Keystroke Dynamics. So it's not big, but for biometrics it's quite big, especially if you think about the time to collect this data. So we have a benchmark with 100 users, and we ask each user to type 60 times the same passphrase. And of course, we made multiple sessions to do that. So we have also the gender information. We will talk about that later. And we collect this data, and we provide this data for everybody in the world. And we try to see what is the performance of published papers on that in 2009. And we propose a method which is, I'll explain you just 2 slides before, which is named Contrib. And
EER value means the error rate, equal error rate, meaning the number of times the imposter is able to enter the system. So in this case, we assume that the user has a password, and we try to know how many times he will be able to crack the system. And for this study, we show that between 6 and 7% of people are able to enter the system, even if they know the password. Of course, it's far away from fingerprint and iris and so on, but it's low cost. It's no modification of the use of password, and of course, it was published in 2009. Of course, we do better now. But it gives you some idea about what performance we can achieve when we use Keystroke dynamics to enhance the security of password. We think that Keystroke dynamics is a good candidate for logical access control to enhance the security of password checking. But I would show you that recently we show that we could use this information for soft biometrics. So soft biometrics is a particular domain in biometrics where we try to collect data on the user that are not sufficient to recognize him. For example, when you talk about soft biometrics, with guys on face recognition system, they try to detect automatically the gender of the user. So we try to say, okay, let's try to use Keystroke dynamics to profile the user. Can we get some information on this user by analyzing Keystroke dynamics? For example, it could be interesting for many applications like that, just illustration. So we try, and my PhD student came one day and said, I would like to make gender recognition with Keystroke dynamics. Say, yes, why not, if you have time. So he tried, and he used our benchmark, because we know the gender of all users. We try to make a learning about the gender information, and on a specific passphrase, if we have data collected from male and female, we showed that it was quite easy to recognize the gender. It's not perfect, but we are near 90% of recognition when we use Keystroke dynamics to estimate if you are male or female. And I said, okay, maybe it's easy because we know the text. Now, can we check on a free text? I mean, for example, you analyze a chat between users, you collect some data, and we try to predict if it's a man or a woman. So we did that, and we used a benchmark provided by Spanish researchers, and we analyzed some D-graphs, particular D-graphs, and could be tuned for each language. And we analyzed this Keystroke information on these D-graphs. And we did that, and we saw that for one sentence, 75%, not bad. And of course, if we collect a lot of sentences from the same person, we can increase the performance of gender recognition. Many people from the media came to me from July this year and said, why are we able to collect gender recognition with Keystroke dynamics? It's very difficult to understand and to explain, but I asked my student to make some analysis about Keystroke dynamics between male and female. For example, he plotted this figure. This figure gives the Keystroke dynamics template, average template for male and female for the first study about the same passphrase. And as you see, the first conclusion is, in average, women are slower than men. It's average because, of course, it depends a lot on the habit, and of course, we are not perfect, it's 90%. But we show this information, saying, okay,
this information about gender recognition with Keystroke dynamics is interesting. Could be useful for any real application or when you use internet. Let's try to do other aspects. So this is the process to detect, and the big difference with the passphrase approach is we use only some features, we use all the information, we use only digraphs from the sentence because, of course, we don't know the word will be typed by the user. But it's, and we compute a score about male probability. We can update this score with time. So we say, okay, one company from said, okay, I will be very, very interested in a system that is able to know if you are over 18 or not. Say, okay, we can try, but of course, in our data, we do not have so much data about over 18 and less than 18, because we need to make learning, okay? So, but in our data, we saw that we have quite correct information about over 30 and less than 30. And also, maybe it is easy to explain because, for example, some people always knew a computer. Using a computer, and especially a keyboard, is very natural. For others, it's not really natural. And maybe the way of typing is different. So we try it directly on free text. And we are, for one sentence, we are 70%. But if we use, again, multiple sentences, and you have here the evolution of the error with the number of sentences we use for the training, for the verification, sorry, we see we can decrease a lot the error. And so we can make a good prediction about 83% if we collect data from 12 or 11 sentences. But you could do that, of course, with much more sentences in order to increase the efficiency of the approach. And also, and one of my students is in the audience, work also on the way of typing. I mean, do you use one finger or multiple fingers when you type? It's a good way also to distinguish some people. And of course, again, if we have some data, and we collected some data, and especially from people from Biometric in Norway, we can show that, again, 85% we are able to recognize that. And of course, it may be sometimes easier because when you type with one finger, of course, you are much more slower than using multiple fingers. So it was just to show you that, okay, we can recognize people with Keystroke dynamics, but also we can, by extracting some data about the user when he types somewhere in the chat or something like that, we can extract some information that could be useful. So, of course, there are many applications on that. If, of course, performance could be increased, but for example, if you know the user is a woman, maybe the design of your website will be different. If you know, if you're supposed to chat with a little girl of 14 years old, with Keystroke dynamics, you analyze and maybe it's male more than 50, so maybe I should cut the discussion between these two persons. So there are many applications on that, and when I was listening to Per, maybe we could give some information to hackers about are you a male or female, and could give some other way of cracking the password. So just two slide conclusion. We think Keystroke dynamics is an interesting biometric modality. It's usable definitely because everybody is used to type a password. It's privacy compliant. Sorry to be compliant. It's low cost. We provide a better security, not perfect, but as it exists.
And of course, we have many trends to be more studied, and we work with Patrick Bose from this lab in Zurich, and especially one attack, and I'm sure everybody knows that attack, it's a replay attack, like also password, I mean. So we try to avoid this replay attack by using a kind of one-time password, but biometric one-time password. So try to embed Keystroke dynamics and change. We try to also to know what we can profile on user. One researcher from US in 2011 showed that we are also able to distinguish emotional state of the user. Could be useful if somebody wants to suicide in your company, to just put the message calm down. And also we are working also on how to generalize this approach to touchscreen, because when you use a touchscreen you don't have a keyboard. But you can do many interesting things, just and we're working on that because as I told you, we work a lot with banks, and especially in France, but not only, many people are working on NFC transaction, so using the mobile phone mainly to pay, and of course to fraud this kind of payment. Good thing is not to be the right user. So we try to propose biometric solution to realize user authentication on a mobile phone, could be usable. We try to propose something which is an update of the pattern-based password. You know, everybody, this way of typing a password on a touchscreen when you have to define a particular way in this matrix. And we try to embed some biometric information in that. For example, the way you realize this pattern-based password, the surface in contact with the touchscreen, because if you have big fingers, we will be suspicious if somebody is using a very thin finger, for example. But we can combine knowledge and the way of doing, for example, this password. And we try to do that. And we think that will be a usable solution for password checking, maybe for NFC transaction, but for other also transaction. We think it is very difficult to forge. Reproducing the behavior of somebody is not an easy task. And we think it is also usable and very fast, because when you think about NFC transaction, it will be quick. So thank you very much for your attention. You have 10 minutes. Wow. I thought it was, okay, it's less than 9. You have the website of the research unit, and if you are interested, you can download the Keystroke Dynamics software. It's only in Windows, sorry for that. And please feel free also to contact me if you have any questions. So now we will have plenty of questions because we have time before lunch. Yes?
So what happens if I break my wrist skiing and I now go from typing with 2 hands to typing with 1? How do I resolve this?
He's never heard that question before.
What happens? You will have problem to authenticate yourself. It's the same if you put your fingers on the car, for example. I don't know. But of course, when you talk about biometrics, most of the time you have an alternative solution. Of course, this alternative solution should not be too stupid. But
password questions.
No, I mean, it could be something else. For example, if you have touchscreen, you can make the pattern bearers the password checking with biometrics, of course. But it's always the same for any kind of user authentication method. Once you cannot use it, or once it doesn't work, because of course, Keystroke Dynamics doesn't work with everybody, because you have to be quite stable. People who are stable, they do not have any problems. But it's the case for all user authentication. Yeah?
So how would this adapt to me evolving the way I type my password after time? Because like when I first choose a password, I'm recalling that password from cognitive memory, and then after I've typed it 100 times, it's all muscle memory at that point, and I'm typing it more efficiently. How does this scale to me evolving the way I type my password after, say, 3 months?
Yeah. So we are working on that, and I don't know if you noticed that, but in the method we proposed in 2009, we have something which is located here, which is update mechanism. So of course, when you type your password, most of the time, you do not think so much. I mean, in general. I mean, you can talk with somebody and you will type your password, and you don't think about that, because what we are interested when we use keystroke dynamics is to capture this reflex. And of course, when you choose your password, and we expect you to choose something which is easy for you to type, and you can train for that. And with time, the way of typing can change slowly. Maybe because, I don't know, because you have the habit to type it. So we can update this mechanism. So I didn't mention that in the presentation, but we worked also on that. And we have some update mechanism. For example, if you type your password and say, oh, it seems to be similar to your model, but it seems to be not exactly the same. So it could be interesting to embed this new way of typing in your model. So we have a second threshold in this case, which is the decision threshold for update. And after we have a mechanism to update this threshold, to update your way of typing. So we have tested that, and especially by considering attacks. For example, I'm a hacker, I try to impersonate somebody, and I try to predict how this guy will type this password. And so we, in the template mechanism, we try to deal with attacks in order not to modify completely the reference of the user. So we have some solution, and it's very difficult for behavioral biometric. Most of people, some people work also on template update mechanism, like face, because your face can change over time. Some people take a picture each day during a long period, so it's also a good material for people in biometrics in order to be able to test whether my face recognition system will be able to recognize the same person 1 year after, for example, the capture of the data. And that's why also in your passport, it's limited time, because they want your face not to move so much during the validity of your password. So you can, with organizational aspect, try to reduce this aspect, but also we have some algorithmic solution. Not perfect, but it increases, it allows not to decrease so much performance.
Okay, thank you.
Yeah.
So if you're talking about a browser, is this something that's going to be done as like JavaScript, for example?
Yeah.
So how accurate is that using Java? Well, there are a few points of that. How accurate is the timing using JavaScript compared to something that would be native to the OS first?
I mean, keystroke dynamics is not so easy to attack. I mean, we know very well how to do that. And also, you can, if you have a keylogger, most of the time you just record what the user types. But also you can record what he types, but also the way he is typing this on the keyboard. So, for example, on the website, you can replay the keystroke dynamic of somebody if you coded it before. And we know this is a way of attacking keystroke. That's why we're trying to make challenge-based keystroke dynamics. But it's very difficult to do that. But
challenge-based meaning you have to do, like, say, enter it, and then you get the challenge back. So you have to type something else, so you get 2 samples.
The idea, many people worked on that in the past. For example, they ask some user, they record the way of typing of some user during 1 month, for example. So we put a kilo here, specific kilo here on your computer, and they store everything what you wrote during 1 month. Based on that, they generate a model of your way of typing. Okay? So in the challenge-based Keystroke Dynamics system, the server will say, okay, type this sentence. You will type this sentence. We will record your way of typing, and the server will predict how you should type this sentence, and we make the similarity measure. So if you have a lot of data to generate this model, it's possible, it's working. But it's not usable. I mean, it's not operational. It's good for research, not good for industry. So we're trying to be able to generate this model with the minimum data of the user. Because if you put a keylogger to generate a model, that means that you propose something for security reason by compromising privacy. So for me, it's ridiculous. Well, so we would like to ask people just type, I don't know, the difficulty is the minimal data, 10 sentences, and based on this specific 10 sentences, we will be able to generate your model. And in this case, you will have something which is low cost and also very good in terms of security, because the replay attack will not be able anymore without having tokens and so on.
Well, if somebody's Trojan, then keystroke, whether it's irrelevant, they can have something to detect that JavaScript file came across. Okay, fine, we're going to record the whole transaction of the JavaScript, and you can, or modify script, and it would be trivial.
James, both special breakout session for you guys for lunch. But yeah, there are several more questions, but I also wanted to add this. When I talked to Christophe the first time earlier this year at Finse, and I heard his presentation on this stuff, and then we discussed him doing a talk here. Yeah. And one of the questions that I had for Christophe is whether they could eventually put up a website that will actually that we can actually attack, that will do the client side Keystroke dynamics for us. And then we can try to attempt to attack that, and they can do they could do it in Microsoft Silverlight if they want to. Well, maybe some of us would still try to attack it, but I think that would be really interesting, because the demo software in Windows is really fun to play with. But I would like to do it on on a live, online, accessible website. That would be much more interesting to demonstrate, to try to attack, and eventually I don't know how it would be with the source code running client side if you are sharing this or not, but I think that would be really interesting.
We should be good to go.
We have, as I told you, we have a Windows software, so you can play with that and just have a look. And we have also internet version, because we started 2 years ago to make a benchmark on the web. So we asked people to type their password during each week during 2 years. So not so many people use this software, but we had a very, very large database now. And we ask also users to type the password of somebody else in order to simulate that or try to impersonate somebody else. So we have everything with, I think it is JavaScript, and we have also the server for the matching. So yes, Per told about that before the conference. We could try to make it available, and if you want to test, and also to be able to crack it, yeah. Okay, thank you very much.